Hey there, welcome back to another exciting episode where we explore the wonders of chemical compounds. Today we're diving into the awesome world of chemical compounds. These fascinating substances are all around us and play a crucial role in our daily lives. What exactly are they? Let's recap. A chemical compound is formed when two or more different elements get together and decide to bond. This bonding process creates a new substance with unique properties. It's like a chemical party where elements mingle and create something entirely new. Think of it like baking a cake. You start with individual ingredients, each with its own characteristics. For example, you have flour, sugar, and eggs. These are like our elements, each one essential but different. When you mix them together and bake, you get a delicious cake, a brand new thing. That's your compound. Compounds aren't just tasty treats though, they come in various forms and colors, each with its own unique set of characteristics. They make up everything around us from the water we drink, which is a compound made of hydrogen and oxygen, to the air we breathe, which contains compounds like oxygen and nitrogen. Scientists study these compounds to understand their properties and how they interact with each other. From the plastic bottles we use to the medicines that keep us healthy, chemical compounds are integral to modern life. Now let's talk about the importance of naming conventions for these compounds. Binary compounds, which consist of two different elements, have specific naming rules to ensure clarity and consistency. Ternary compounds made up of three different elements follow another set of naming conventions, and quaternary compounds, which include four different elements, have their own unique naming guidelines. These naming conventions are crucial for scientists to accurately communicate and understand the vast array of chemical compounds in our world. Let's take a moment to understand the language of compounds. This language, known as chemical nomenclature, is like the grammar and vocabulary of chemistry. When chemists name compounds, they follow a specific set of rules to ensure clarity and precision. These rules help scientists around the world communicate effectively about the substances they're working with. First, let's talk about binary compounds. These compounds consist of two elements. The name usually combines the names of the two elements with the second element ending in "id". For example, sodium chloride or NaCl is a binary compound made from sodium and chlorine. Another example is carbon dioxide or CO2, which consists of carbon and oxygen. The naming rules for binary compounds are straightforward. The first element retains its name, and the second element's name is modified to end in "id". Next, we have ternary compounds, which contain three elements. These often include a polyatomic ion, a group of atoms that act as a single unit. An example is sodium sulfate, or Na2SO4, where sodium is combined with the polyatomic ion sulfate, consisting of sulfur and oxygen. Another example is calcium carbonate, or CaCO3, which includes calcium, carbon, and oxygen. In ternary compounds, the polyatomic ion's name remains unchanged, and the other elements are named as usual. Finally, there are quaternary compounds, which contain four elements. These can be more complex to name due to the increased number of elements involved, but the basic naming principles still apply. For instance, ammonium phosphate, or NH4, 3PO4 includes nitrogen, hydrogen, phosphorus, and oxygen. Another example is potassium ferrocyanide, or K4Phe, CN6, which contains potassium, iron, carbon, and nitrogen. Understanding this chemical language is crucial for anyone studying or working in chemistry. It allows for accurate identification and communication of chemical compounds, ensuring that scientists can share their discoveries and collaborate effectively. Now that we have a grasp on the language of compounds, let's move on to see a chemical reaction in action. Want to see a compound in action? Here's a simple chemical reaction for you. Two H2 gas molecules plus one O2 gas molecule react to form two H2O liquid molecules. This equation shows how hydrogen gas, H2, reacts with oxygen gas, O2, to form liquid water, H2O. Now let's talk about naming binary compounds. These are compounds made of two different elements. For example, H2O is called water, but its systematic name is dihydrogen monoxide. Notice how the elements combine in specific ratios? This is crucial in naming and forming compounds. This reaction is also balanced, meaning there are the same number of each type of atom on both sides of the arrow. Chemistry is all about balance. Some compounds, like sodium chloride, are made up of tiny units called molecules. A molecule is a group of two or more atoms held together by, you guessed it, chemical bonds. Think of molecules like tiny Lego structures. Atoms are the Lego blocks. and bonds are what hold them together. Different molecules have different shapes and sizes depending on the atoms involved. Sodium chloride, NaCl, is a molecule, and so is carbon dioxide, CO2. Now let's talk about how we name these compounds. Compounds are named based on the elements they contain and their proportions. For instance, NaCl stands for sodium chloride, and CO2 stands for carbon dioxide. Understanding these naming conventions helps us identify and communicate about different compounds effectively. Formula units representing ionic compounds. Now remember how I said not all compounds are made of molecules. Enter formula units. Formula units are the smallest repeating patterns in ionic compounds. Ionic compounds are formed by the attraction between oppositely charged ions. A classic example is table salt, NaCl. The formula unit NaCl represents one sodium ion, Na+, and one chloride ion, Cl, held together by ionic bonds in a crystal lattice structure. When naming ionic compounds, the cation, positive ion, is named first, followed by the anion, negative ion. For example, in NaCl, sodium is the cation and chloride is the anion. This naming convention helps in identifying the components and structure of the compound. Covalent bonds. Sharing is caring in the world of atoms. Let's talk about the glue that holds atoms together in compounds. Chemical bonds. We'll start with covalent bonds. In a covalent bond, atoms share electrons to achieve a stable electron configuration. It's like sharing your toys with a friend so you both can have fun. Covalent bonds typically occur between nonmetal atoms. Now let's focus on how we name compounds formed by these bonds. For molecular covalent compounds, we use prefixes to indicate the number of each type of atom. For example, CO2 is carbon dioxide, where Di indicates 2 oxygen atoms. Network covalent compounds, like diamond and quartz, are named based on their constituent elements and structure. Ionic bonds, opposites attract, forming strong connections. In ionic bonds, it's all about attraction. One atom donates an electron to another atom, creating ions with opposite charges. These opposite charges attract, forming a strong bond. Think of it like magnets. Opposites attract. Ionic bonds usually occur between metals and nonmetals. For example, in table salt, NaCl, sodium, Na, loses an electron to become a positively charged ion, Na+, and chlorine, Cl, gains an electron to become a negatively charged ion, Cl1. When naming ionic compounds, the metal ion is named first, followed by the nonmetal ion with an -id suffix. For instance, NaCl is named sodium chloride, and MgO is named magnesium oxide. This naming convention helps in identifying the components of the compound easily. Ions, charged atoms with a big role to play. Ions are charged atoms that play a crucial role in chemical bonding. They can be positive or negative depending on whether they lost or gained electrons. Think of them as atoms that have gained or lost a tiny bit of electricity. Positive ions are called cations, and negative ions are called anions. Ions can be single atoms like sodium ion, Na+, or groups of atoms like the sulfate ion, SO42. When naming compounds involving ions, the cation name comes first, followed by the anion name. For example, sodium chloride, NaCl, combines sodium ions and chloride ions. Another example is calcium carbonate, CaCO3, which includes calcium ions and carbonate ions. The periodic table is a powerful tool for chemists. It provides valuable information about elements and their properties. One of its key uses is in naming compounds. For binary compounds, which consist of 2 elements, the periodic table helps determine the correct naming conventions. For ternary compounds, which include 3 different elements, the table aids in identifying the elements and their ratios. Quaternary compounds, containing 4 elements, also rely on the periodic table for accurate naming. By understanding the periodic table, chemists can systematically name binary, ternary, and quaternary compounds with ease. Naming compounds, a system for chemical communication. Just like we have names to identify each other, chemists have a system for naming compounds. This system is known as chemical nomenclature, and it is essential for clear and precise communication in the scientific community. This system ensures that everyone understands which compound is being discussed. Without a standardized naming system, it would be nearly impossible to share and build upon each other's work effectively. Binary compounds, formed from 2 elements, typically have the name of the first element followed by the name of the second element with an ID ending. For example, Nasal is sodium chloride. Sodium, the first element, is followed by chloride, derived from chlorine with an ID ending. Another example is H2O, which is water. Here, hydrogen is followed by oxygen with an ID ending, forming oxide. Ternary compounds contain 3 elements, often including a polyatomic ion. For example, Na2SO4 is sodium sulfate. Here, sodium is combined with the polyatomic ion sulfate, which consists of sulfur and oxygen. Another example is CaCO3, known as calcium carbonate. Calcium is combined with the polyatomic ion carbonate, which includes carbon and oxygen. Quaternary compounds contain 4 elements. These compounds can be more challenging to name due to the increased number of elements involved. For instance, SO4 is potassium aluminum sulfate. The naming conventions can get a bit more complex, but the basic principles remain the same. Understanding these principles is crucial for anyone studying or working in chemistry, as it allows for accurate identification and communication of chemical compounds. This system of chemical communication is a foundational aspect of the field, enabling scientists to share their discoveries and collaborate effectively. Practical applications of these naming conventions include pharmaceuticals, where precise compound identification is critical for drug formulation and safety. Real-world applications of chemical compounds. Now that we have a grasp on the naming conventions for binary, ternary, and quaternary compounds, let's explore how these compounds manifest in our daily lives and why understanding their names is so important. The toothpaste you use contains sodium fluoride, a binary compound that helps prevent tooth decay. When you cook breakfast, the table salt you sprinkle on your eggs is sodium chloride, another binary compound. Hydrogen peroxide, another binary compound, is commonly used as a disinfectant for cleaning wounds. Ternary compounds also play a significant role. Take calcium carbonate, for instance. Found in antacids, it helps neutralize stomach acid, providing relief from heartburn. Sodium bicarbonate, or baking soda, is another ternary compound used in baking to help dough rise. Ammonium nitrate, a ternary compound, is widely used in fertilizers to promote plant growth. Quaternary compounds, though more complex, are equally essential. An example is ammonium dichromate, used in some scientific experiments and industrial processes. Another is potassium aluminum sulfate, commonly known as alum, used in water purification and in some food preparation processes. Quaternary ammonium compounds are also used in disinfectants to kill bacteria and viruses on surfaces. These examples highlight the practical significance of understanding chemical compounds. Knowing their names and properties allows us to appreciate their roles and make informed decisions in our daily lives. So, the next time you brush your teeth, cook a meal, or take an antacid, remember the fascinating world of chemical compounds at work behind the scenes. Stay curious and keep exploring the wonders of chemistry. Conclusion: the importance of naming conventions for compounds. Naming conventions for binary, ternary, and quaternary compounds are crucial in chemistry. They provide a systematic way to identify and communicate about compounds. These conventions help scientists understand the composition and structure of compounds. Accurate naming ensures clarity in scientific research and publications. It also aids in predicting the behavior and reactions of compounds. In daily life, proper naming helps in identifying substances in food, medicine, and products. From the ingredients in our meals to the active components in medications, naming conventions play a vital role in ensuring safety and efficacy. So, understanding these conventions is essential for both scientists and consumers. They are the foundation of clear and effective scientific communication. Make sure to give this video a like and subscribe. Have a nice night and